Greetings and salutations. This is going to be a good video. We are going to unleash the awesome power of SSH. In this video, I'm going to show you how to set up SSH on your local network. If you like what you see, give the video a big thumbs up. That helps YouTube to know that people want to see content like this, and they'll put it in front of more people. Also, if you are not already subscribed, please consider subscribing to the channel. It's a big help, and I want to say thank you to all the folks who have subscribed lately. We've had a big influx of new viewers, and that's really awesome. Thank you very much. I'm very glad that you're here. Somebody posted a comment a little while ago, and they said that they would like to see a video about Linux networking. When I saw that video, or rather that comment on the video, I said to myself, I don't know anything about Linux networking. I mean, what am I going to say? And then I realized the reason why is because I use SSH for everything that has to do with networking on Linux. It'll do pretty much everything that you need to do as a home user or even in a small business. So today I'm going to show you how to get started with SSH. In all of the videos that I've posted recently, at some point I mentioned some tool that I'm using with SSH, but I haven't showed how to set it up on this channel in a very long time, so we're going to try and do that today. I went out and did a little research, and I found out that a lot of the tutorials that you find online are complicated and somewhat needlessly, because everybody seems to have their own twist on how to set up SSH. SSH is really part of the core of Linux. It's been around for a very long time, and those who have been using it have their own ideas about how it should be done. The way I'm going to show you today is the easiest. We don't have to edit any configuration files. We'll take a look at what's in them, but we don't have to edit them. We don't have to do much on our network machines to make this work. It's actually quite easy. We'll set up static IP addresses. We'll install the SSH server, and that's just about it, and then we'll be up and running. Before we get into all of that stuff, we need to take a few moments and we need to talk about the plans that we need to make to get SSH running, and we got to think about how we're going to use it. This is a typical network for most of you guys who are watching. Even a small business would have a network just like this, but this is a very typical home network today. So we start over on the left with the internet, which is represented by a cloud. There is no cloud. It's just somebody else's computer. The internet is nothing more than a whole lot of computers that are available on a very big network. And between the internet and your router, you have a firewall, which is represented by just a little brick graphic thing there. We'll talk about that in a moment. The router itself, it takes stuff from the internet and it distributes it to all of the devices on your local network. What it does is it creates a subnet. That subnet is protected by the firewall. The firewall, by the way, is in the router, but it's easier to represent it as being something else because it really is the last defense before you get to the public internet. And essentially what a firewall does is it does not allow anybody on the internet to see any of the devices running on your network. There are no ports open. It's not going to let any servers advertise themselves on the internet unless you set it up to do so. Once a server is advertised on the internet, in other words, you have a port open at this IP address, you also have to have some way to find that. That IP address is going to change because ISPs do not give you fixed IPs unless you pay a lot of money, and they really don't like setting them up. So yes, it is possible to set up SSH in such a way that you can access it from the public internet, like you could be sitting in a hotel room halfway around the world and log into a computer at your house. But that's beyond the scope of this video because you would have to get a domain set up, you would have to configure your router to allow the port to be advertised through the firewall. It gets to be very complicated. So we're not going to worry about that today. I don't have my system set up that way. I've never set it up that way. I have found that I can use SSH on my local network for all of my networking and administrative stuff. And if I need to do something that's outside of my network on the internet, then I can access a machine through SSH. And once you set the tunnel up, it's two ways. You can have data that goes back and forth, the SSH tunnel. And so therefore I've never had the need to access anything at my house from outside of my house. And honestly, I don't think most people will. But if you would like to take that extra step, be my guest. So there are a few terms that we have to talk about before we get into this as we're planning what we're going to do. If you've been around the block, you already know what this is all about. This might seem a little boring to you. You can skip ahead a little bit if you want to. But if you're just starting your Linux journey and you're new to SSH, then it helps to understand these few basic terms. First is DNS. That's the domain name system. That's how the internet works. If you sit down at a browser and you type in youtube.com, what happens, the browser contacts a domain name server, a DNS service, and it says, I've got this name, youtube.com, look that up and tell me the IP address. And the IP address comes back from the domain name service, and then the browser opens up the web page directly. That's why you can have DNS problems. You could have it where things open up slowly if your DNS servers are acting up or whatever. This is the first step to accessing anything on the internet. And we're worried about that because we need to get around not having that on our local network. These days, most local networks do not have host name servers, which is kind of like local DNS. Now, older routers, 10, 15 years old, this used to be pretty standard. They would have it on there. And so that if you wanted to access a computer running on there that had a host name like Big Boy, like this one does, you would just type in SSH Big Boy and it would figure that out for you and you'd be on. But that isn't happening anymore. Could we set up our own local hostname server? Absolutely. It's easy to do. You could have it running on the same computer that your SSH server is on. But that's beyond the scope of the video. And also, I find that it's just as easy to use IP addresses, and I have a couple of tweaks that makes it super easy to do. And so assuming that you don't have, more than 10 computers on your network, this should be pretty easy to keep track of. So the next thing we need to talk about is DHCP. That's Dynamic Host Configuration Protocol. What that is how your router assigns a local IP address to machines and devices that are hooked up to it to gain internet access. A new machine comes on and it says, you sign in with Wi-Fi or you plug in an Ethernet cable, however you do it, and it goes, oh, look, a new device. Let's find it an IP address. So it sets up a lease. And for a period of time, this device can use that IP. If the device is still running when the lease is up, it renews the lease. It says, oh, you're still here. Okay, keep your IP address. When that machine turns off, that IP address is now freed up. And so it could be reassigned to another machine. This is why we need to set up static IP addresses if we're going to use IP addresses to address our machines. This is how we're going to find them. Setting up a static IP is super easy. I'll show you how to do it in very minute detail shortly. Of course, a LAN is a local area network. That's what we're concentrating on today. And then SFTP is the SSH File Transfer Protocol. We're going to look at that. That's a really nifty way to get files from a server or transfer files even to a server from a client. And then there's the SSHFS file system. Now that is a more traditional file share where we have a directory on a remote machine that appears on our local machine as if it is part of the local file system. And that would be more like using Samba or NFS or something like that, which is more of a dedicated sort of thing. And so let's go ahead and get into setting up an IP address. So the first thing that we have to figure out now that we have all this information is how are we going to access SSH on our network? You could very well choose to have one machine running a server and then all the other machines log into that machine. And you can do that if you're using it for like file transfer or whatever. Every Linux system that you sit down in front of has SSH up and running as a client. In other words, you can log into any system that you have a way to get into with SSH as soon as you install Linux. And I used to have a server that ran in the cloud. There's no such thing as the cloud, it's just other people's computers, I know. But anyway, I could access that server if I was working on a client's computer. If I was setting up somebody's machine and I was at their house, it didn't matter. As long as I had internet access, I could get to this machine and I could get the resources I needed, scripts, whatever that I wanted to run locally. So that's kind of one way to look at it. You could also have it where all of your Linux machines, at least, are running SSH servers. This is how I do it on my local network. No matter what machine that you're sitting in front of on my network, you can access it by using SSH or other machines. It doesn't matter. It goes both ways. And I'll show you how to do that. But first, let's go ahead and set up a static IP on our first server, because we're going to have to do that first to get started, and then we can worry about distributing this across the network. So we have to set up the static IP, and we need to know some things to make that happen. So I'm going to open up a terminal on the host machine here, and we do have a VM up and running that we're going to be working with as well. But we're going to kind of go through the steps of setting up a static IP on this host machine that's already running SSH. And then we will get into it from a client. So the first thing that we need to figure out is our IP address on the local machine, and we also need to know the netmask. There's a couple of ways to get that information. There is a piece of software that should be on just about every Linux machine you sit down in front of, and it's called IP. I don't like it, but it's universally available, and for some reason or another, people think this is somehow better than the older way of doing it with ifconfig. Let's run IP with the argument A, and you don't even need the dash. I just noticed in my notes here, do you see that right there, that I had put a dash there? You don't need that. I think it'll still work. Let's try it real quick. Clear the screen. I want to make sure it works if people are following along with the notes. No, you get something different. That's another reason not to like this program. I'll fix that when I put it in the description. You remind me, so I'll make sure I do that. You can't use -A. These guys got to be different and just use A when the protocol for every Linux program is dash when you want to have an option. Okay, anyway. Here's what the output looks like, and it's another reason I don't like this program is it's a bunch of gobbledygook, and if you don't know exactly what you're looking at, it's difficult to figure out, but I'm going to help you navigate. So here we go. So the first interface that we see is the number one here is loopback. Loopback is the local network running within your machine. There's actually a network running in the machine. I know it's a mind blower, right? So we have 3 networks now that we're actually talking to. We've got the local network on the machine, we've got the local area network that's being run by the router, and then we got the internet. And we're not going to worry about the loopback. The second one we see here is Ethernet. Nothing's plugged into it, so we don't have any addresses. And then number 3 here is the actual network that we want to look at, which is WL. This would be wireless LAN, and that's how we're connected to the internet, is through Wi-Fi. And if we come down here, you'll see iNet. iNet, that's our IP address, and our netmask is right there, 192.168.0.11/24. That tells us everything we need to know, believe it or not. And then down here, this one you see is a virtual network that is acting as a bridge between the virtual machine that I have up and running and the local machine on the host. That's the way GNOME Boxes decides to deal with networking. They set up a little virtual bridge. I have to say that I kind of like VirtualBox's way of doing it because you can set it up for each individual machine, but that's okay. So now let me show you the piece of software that I would rather use to find this information, but this may not be installed on your system automatically. So let's go ahead and clear that. Control L. We'll do ifconfig. Doesn't that look a lot better? Makes more sense, don't it? So the first connection that we see is Ethernet. We have nothing plugged in, so nothing's going on. And then we have the loopback. And then we have that virtual bridge for the virtual machine. And it's got an iNet of its own. We're going to ignore that because we want the wireless LAN connection. And once again, you see that we have iNet 192.168.0.11, and our netmask here is expressed as 255.255.255.0. For this particular network, 24 and that 255 netmask are actually the same thing. It has to do with math, and it's over my head, so I can't explain that to you, but you can go look it up if you want to. Learn all about netmasks. If you want to use ifconfig, you will probably have to install a package on any Debian-based system. That would include Ubuntu. So anything with a deb package format, you would have to install a package called nettools, NET-TOOLS, and then you would have ifconfig. But if you can figure out how to use IP, you don't have to do that. So what's the next thing we need? We need to figure out what our gateway is. And the gateway would be the IP address on our local network of the router. This is how machines get the internet over a local network. They go and ask for it from the router. And so we need that. And to get it, we will just run the command route and n with the proper option here with the hyphen or the dash, whatever you want to call that. Unlike IP. So gateway, there's only one listed, and that's 192.168.0.1. There really can't be two, but I guess in some weird configuration you could have that, so that would be really confusing. You would have to know which one to use. We're not even going to address that issue here, but hopefully you only see one. And by the way, it might not be a network address or an IP address starting with 192. This could be any combination of numbers. Just don't be thrown off if you see that it's not a 192 type address, but a lot of home networks use this setup, this netmask. So we have all the information we need. Where do we put it? To set up a static IP, all we got to do is jump into settings. We're in Ubuntu on this machine. While I'm here, I can go ahead and close that. And we are going to go to settings. And this may be a little bit difficult to see on small devices. But you'll get the idea because you're just looking at the locations of where things are. If you're following along, then it'll make perfect sense. So it's already on Wi-Fi over here, which is our connection. We find our network, which is Linux Land 5G. Isn't that a cool name? Yep, it's mine. And then over here, we're going to click on the little gear, and we're going to look at the settings. What we're worried about is IP4. And this is probably already set up as automatic, DHCP, the system that provides an IP address when the computer asks for access online. We're going to change that to manual. And when you do that, what is going to happen is we're not going to use DHCP. What we're going to do is tell the router what IP address we want when the machine boots up. So you have to pick an IP address that you know is probably going to be available. My machines always start with 11, a low number. I've noticed that DHCP usually hands out automatic addresses that usually are 3 digits, like 123 or something like that. So I keep it very low, and that way I am avoiding any possible conflicts. Of course, the router can figure that out. If it's already got a leased IP for another machine, it may be able to change that dynamically depending on the software. But on a small network that you're running just a few devices, it shouldn't be that big of a problem. And this is my main machine. I consider this to be the main host. So it starts out with 11, and then as the other machines on the network go up, we go up in numbers. So this is our IP address here. This is the one we want. It's not the one we have, it's the one we want. So remember that when you're putting that in here. Here's your netmask, 255.255.255.0. You can also just type in 24 in this instance. And then over here, this is the gateway, 192.168.0.1. So now the system has all of the information it needs to hit the router without waiting for the router to figure out it's there. And it'll just say, I'm here, give me this IP address. The router says, okay, boom, done. And we can also configure DNS for a custom DNS, and mine is configured for custom. I use Cloudflare DNS. I don't use the DNS from my ISP. It's just an extra little bit of security. It's kind of beyond the scope of the video, so I'm not going to get too much into that. There's one more tool that we should take a look at, because this one will probably be more familiar if you're not somebody who's using Ubuntu, where they have their own little custom settings there. If we go to Ubuntu, we type in net, we get advanced network settings, and this is the normal network manager interface. It actually is a bit more logical to me because it shows the connections. So we have the wireless connection, or rather the wired connection that we're not using. And if you, by the way, if you plug a Ethernet cable into your computer, an Ethernet cable, grammar counts, you will automatically be switched over to that better connection. That's usually the way that Network Manager works. I think it does the same thing in Windows as well, and in Mac. It's just pretty much standard, where it'll say, oh, there's a better connection here, and it'll switch you over in the background. The LAN, of course, is right here. And then there's that virtual network that we were talking about earlier. So if I click here and then I go to settings, we're going to see a very similar window. And we're going to go to IP4 settings again. And now we have the same values, except the netmask here is expressed as 24. You can type either one in there. It's fine. IP6 settings, I forgot to mention that. We just want to disable that. Just disable it or ignore it. IP6 will take care of itself. IP6 is, there are so many numbers that it's almost non-humanly readable, so we're not even going to mess with that. And that's kind of the way we're working it these days. So on local networks, we're using IP4 addressing to do things like we're doing today. IP6 is more automated. It's there in case we run out of IP4 addresses, which is not impossible. So once you have that in, and assuming that it took all that information without complaining, you should now have a static IP address. And if you disconnect and reconnect to your router, then you should be on that new static IP. Once we have that done, you can now install openssh-server. Different distributions of Linux handle setting up the server side of SSH differently. In Debian-based Linux, that would be Ubuntu, anything based on Ubuntu, anything based on Debian, anything where you're dealing with a deb package. You will need to install a package called openssh-server. And what that does is it activates the server side of SSH. The client is running on every machine, as I had already said. You just sit down, it's there. But the server, you have to activate. When you install it, that server is up and running immediately, and the next time the machine is booted up, it will automatically be running in the background. It becomes a service. It's there all the time. So once we have our server set up, we have our static IP, go ahead and reboot the machine, and we should be able to log into it. So we are now looking at our virtual machine, and I'm not going to worry about that right now because there's nothing to back up. It's a virtual machine. Use Control-T to open up a terminal on this virtual machine, and we now should be able to get into SSH. Now, what I have done on this machine is I have removed the local SSH configuration folder. Let me just double check that I did that. Oh, I need the long option. I need the A option to see everything. Let's see if, well, no, I didn't. So let's go ahead and get rid of that. So we are going to just do rm r.ssh. And this will make it like we are starting SSH for the first time on this machine. There are no configuration files. So if we want to log into our server, how do we do it now? I'm going to show you the long way, I'm going to show you a shorter way, and then I'm going to give you some advice to make it even easier. Because we are using IP addresses, we are going to have to type in the IP address every time. And I found a way around that by creating a little stub script I will share in the description of this video. You can copy and paste it and make it executable if you wish to make that work, and just put that where it can be executed on your machine. Your local bin folder is a great place for that. Just create bin and throw it in there. Next time you boot the machine, that will be the first place that Linux looks for anything you try and run from a terminal. But the first time that you log in, we're going to do SSH, and we're going to do Joe at 192.168.0.11. Now, I am telling it what account I'm logging into. If, as it is in this case, you have an account on your client machine that has the same name as your server machine, then you don't need to add the Joe at part. You could just put the IP address. So when we do that, the first thing that comes up, it says yes. We're going to say yes, rather, because we know exactly what's going on. And this is, SSH will do this every time that you log into a new host. They'll stop and say, do you really want to do this? Yeah, especially if you're doing this on the internet, some sort of cloud-based SSH, you're going to want to review this before you hit yes. In this case, we know it's us, so it's okay. The next thing it's going to ask for is a password. This is the password of the account we're logging into. Not on your local machine, not your normal password. If they are different passwords, you'll have to give it the password of the account you're logging into. And we're in. So, before we go on any further, I want to talk a little bit about alternatives to using IPs and why I choose to use IPs. Could you set up a name server on your local system? Absolutely. You could do that, but that is a bit of work. And so therefore, we are not going to be doing that today. We would have to install the software, and then we'd have to edit configuration files to get it going, and that's beyond the scope of the video. If you want to look into how to do that, go ahead. Just look up installing name server on my local network. That used to be on routers. It used to come as a feature, but they've dropped that in the last 10 or 15 years. So usually on a local network, there is no name server, and we're talking a lot, about like DNS. There is another way to use host names on your local system, and that is to edit the hosts file of every machine. You probably don't want to do that. So I'm going to go ahead and exit this connection. We're going to take a look real quick at the hosts file on this machine so you will see what I'm talking about. So we're going to use cat, and this file lives in etc/hosts. And there's not much here. It's a very small text file because the only two hosts we have are local hosts and Big Boy. This is that internal network we looked at earlier. So 127.0.11 is the address within this machine to this machine. And we could actually use that to log into the machine ourselves if we wanted to. And I'm going to show you that in just a moment because it demonstrates one of the security features of SSH. But what we could do is we could edit this file, and starting under these two lines right here, we could, if we wanted to, add 192.168.0. whatever, and then the name of the machine. We could keep going with every machine on our network. When you go on the internet or when you use SSH, this is the first place it looks, is your hosts file. So you could even put in like dark web IP addresses here and give them names, and you could get into your like own servers this way. And it's actually a pretty neat trick to do. If you know what the static IP is, and as long as that never changes, just put the IP in and then put the host name in, and boom, you're in the system. This is a bit cumbersome though, and of course we're now editing files, and I guess it's okay if you have like 2 machines on the network, but if you have a whole bunch of machines on the network, then you're going to have to keep up with that. Every time that you add a machine or take one away, you'll have to go into the hosts file on every machine and edit it. Believe it or not, this is how the networks, the internet started. This is how the internet started. Before there was a World Wide Web, there were search engines and all that stuff, and there was no domain name system. Then you would have to add whatever website you wanted to go to into your hosts file on your local machine to get to it. So you could imagine that after a while, as more pages proliferated across the network, that got to be very cumbersome. So that's why we have DNS and the World Wide Web and all that stuff. So anyway, I don't bother with this. If you want to, you can do that. And we have to set up static IP addresses anyway to make that work, so we're not going to deal with it. So let's go ahead and get out of here. I exited the terminal, which is not what I wanted to do. I thought I was exiting SSH. That's another thing that can happen is that you can get confused and you can forget what computer you're logged into. Okay, so now when we log into SSH, we're going to be prompted every time for a password. This is password authentication. It is on by default in SSH, and yes, you can do this. But if you want to use any of the more sophisticated networking tools that go along with SSH, passwords are going to be a problem. So we need to find a way to get into our system without having to type a password. And we're going to do that by generating keys. So let me exit one more time. And we're going to go over here and look at the notes. So let me get out of the VM here. And we are going to use SSH Keygen to generate keys. Now we're going to paste that in there and unhighlight it. So let's break this command down. SSH Keygen, well, that's pretty self-explanatory. We're making a key. What type of key is it? Well, the T option allows us to choose the type, and we're using RSA, which is pretty standard for SSH. It's an old encryption system. It's been around for a long time, but it's actually extremely secure. This is a very secure way to log into SSH. I have had servers running online that I've used keys on that people were just banging on to get in, because if you have a public server running SSH that it's available on the internet, bots will figure out that it's there and they'll try and get into it. And like my web page, when I was hosting it, every time that I would log into that through SSH, it would actually tell me how many people tried to get into it that weren't me. It was scary. So with keys, it's extremely secure. And some administrators have you create a key and turn off passwords. I think GitHub does that now. They expect you to use an SSH key to get in, so that's what we're doing today. Although I have to tell you, on my public-facing servers, I always had passwords enabled, and nobody got in anyway. That's because I use a relatively obscure password, I guess, you know. But if you want ultimate security, turn off passwords, I guess is the moral of the story. So we have RSA, and then we're going to tell it how long of a key we want to generate. And this is either bits or bytes. I can't remember which. I think it's bits. You can tell me in the comments if you know. Here we have the C option, which allows us to leave a comment at the end of the key, and this is how we're going to find the key and where it was generated. And in this case, we're just going to put in, you can put anything you want in here, it really doesn't matter, but I'm going to put in Joe at Ubuntu VM. So there's our key right there. Now it has generated the key, or it's going to rather, and what it's going to do is put it in a file called it's in the directory .ssh. This is on the local machine, by the way, and it is /idrsa. This is your key. You do not share this with anybody. This is your private key, and you need to be kind of protective of it. You don't put this up on a cloud server. You just want to send the public key. We'll talk about that in just a minute here. So we're going to go ahead and accept that location for our key. It's fine for it to be there. Now it's going to ask for a passphrase. Now this is a way to make a key stronger. But it's kind of silly because when you want to use the key, it's going to ask for the passphrase. We're trying to get around that. Unless you are trying to be super duper secure somewhere and working on some dark web site, you probably don't want to mess with this. So just hit enter and hit enter again, and the keys are generated. Where did they go and what do they look like? Well, we'll look at that next. So let's go to .ssh. Well, we have to tell it we want to go there. Gee. We're going in there, and we are going to list and see what files we created. So right now we have authorized keys, we have IDRSA pub, known hosts, and known hosts old. The authorized hosts file is where public keys are stored. So if you send a key to another machine, this is where it looks first to compare it with your private key. The IDRSA is you. IDRSA pub is the public key in its own file. Known hosts are machines that you have logged into, and known hosts old is a backup. So there's known hosts just tells SSH what machines it can log into. It's sort of like a little security feature. When we said yes when we logged in, this is where it was added, is in there. So it's not readable. It's all gobbledygook if you look at it because it's encrypted. We will look at the IDRSA key and see what's in there. Show you what the key looks like. It's a whole bunch of characters. This is your private key, by the way. IDRSA. So keep this on your local server. I can't keep this on your local client machine. Now, if you're working on a network, your own subnet, and you want all of the machines to be able to talk to each other, in other words, every machine is going to have a static IP, every machine is going to be running SSH, there's a trick that we can do to make it so that all of the machines have the same keys, and so therefore any machine you sit down in front of, you'll be able to hit another machine. That's, of course, only on a local network, and you want to do that with accounts that you own. So they are yours because we're going to put that private information in every one. And that's fine behind a firewall. That's plenty secure. It's not that big a deal. So let's clear the screen, and we will look at our public key to see what's in there. This is the key that we share with other machines. It's much shorter, And you notice down here we have our comment at the end, right there, that lets us know where this came from. This is the public key from this machine. So now that we have that set up, we're going to have to send this public key over to the host machine with the server running on it to let it know that we're using keys. What we're going to do is we are going to use a little utility called ssh-copy-id to send that over to our server. So we're going to put our public key there. And we just put in the name of the account we want to send it to. So in this case, it's going to be joe at 192.168.0.11. And it is going to ask for the password. And it says that it has sent those keys over. So now, to see if it works, we just SSH into that machine. So let's do SSH 192.168.0.11. Now remember, I'm going to show you a little shortcut so you don't have to type all that in every time. But in this instance, let's see if we just jump right in. Well, boom, our keys work. We're in. Now we can use more sophisticated stuff with SSH. So let's jump over to our host machine, and we'll open up a terminal here again. And what I want to do is just show you where the key went. So we're going to get into our SSH folder, and we're going to cat authorized keys. Now don't worry, I'm not showing you anything here that is going to compromise any of the security on my system, because we're just looking at public keys. Remember, the private key is on your machine. So there we go. There's our public key, and it is in this file. If we add more keys, or other users add keys to this machine, this is where they will appear. Yes, and other users, if they have your password, can get into your account. You can get into other users' account. If you're an admin on your network, you should know the passwords of everybody on your system. And so you should be able to get in and do whatever you need to do. So SSH is up and running. It's ready to go. What if you have a problem getting SSH to connect? Well, what may have happened is that when you set up your server, you may have a local firewall running on the machine. And if that's the case, that's going to be a problem, because it might not be allowing the SSH server through. So if you can't make any of this work, we need to double check that that's not the problem. So in the past, I have told everybody that you need to set up a firewall, and the little tool that we use to do that is GUFW. So we're looking on the host machine, and I'm going to show you that if you're going to be running an SSH server, that you need to go in here where it says rules, and you need to, in this case it's already here, you see we have a rule for SSH. So I'm going to go to add, do a search down here for SSH. It's going to warn me, it does right there, that this might be dangerous, but we're doing this for ourselves, so we know it's okay. So go ahead and open up port 22 on your local machine, on your server, for your network. I had forgot to show you that earlier, so I wanted to make sure I stuck that in there. It's also not in my notes, but that is an important point, because that will people will put up comments and go, it's not working, I don't understand why. Well, check your firewall, because you're running a server. Now that we have SSH up and running, what can we do with it? Well, we can do a lot with it. So one of the first things that I want to show you is SFTP. Now I have in the notes for this video a bunch of commands. SFTP is a way that we can transfer files back and forth. And if you've been around for a long time, you may Notice that this operates a lot like the old FTP client from years ago. File transfer protocol is sort of going away on the internet these days. I don't even think Google Chrome supports it by default anymore. You have to put in a plug-in or something. But if you're old enough to remember using it, it's kind of similar. So we're going to SFTP, and we're going to go to 192.168.0.11. And we get this little prompt here. And this is a little bit cryptic because it's not a normal prompt, but you can list what's on the machine you just logged into. We've logged into the home directory there. You see that that is the same. We can also use LLS to list on the local machine. So this is the home directory on the local machine. And we could change directories on either machine. That's super easy to do. So we're going to change directory on the host. Let's go to music. And we're going to LCD, local change directory, to music on this machine. Now, we have that. We can go ahead and get some files. So we can get one file at a time, which I'll show you shortly. But let's go ahead and get a whole directory of stuff just so you can see it in action. I'm going to get pop 50s, which is a whole directory of music. And this is going to go out, grab it from the host, and put it on the local machine. That was a mistake. I should have put R for recursive because this is a directory. So remember when you're working with directories to put that there. And it'll just go grab all this music. It won't take long. It's bringing it over. Here it comes. Okay, done. If you get confused, by the way, I'm clearing with Control L again. Clear should work as well. Nope, invalid command because we're in SFTP. Control L is the way to go with that one. Anyway, we can get individual files. If you've changed your directories and you don't know where you are, you use PWD, present working directory, and it'll show you that on the host you are in Home Joe Music, and then what we're going to do is we're going to do the same thing. LPWD. What is the local directory? Well, it tells me that I'm in music again. So in this case, I want to CD and just go back to home. So I'm using the tilde. That doesn't seem to work this way, so we'll do CD. Let's just go one up. So I'm in the home directory there. We can LCD and do the same thing. Just go one up. And now we can get files and put files. So, for instance, we'll get the avatar here and, get .face. You can do it one file at a time, or you can do a whole bunch of files. And now if you want to send things to the other machine, we can use the put command. So once again, we'll just put that file right back. And it's just really that simple. There are some other things that you can do here. You can remove files. You can create directories. It's a really fun little program to play with. I have a few example commands in the description. So we're going to go ahead and exit that. And then I am going to go ahead and delete the 50s out of music. And the reason why is because we need to have that directory being empty for what I'm going to show you coming up here. So, I got to go pop. Well, it should be right there. I don't understand. There it is. I just typed it wrong. So let's go ahead and get rid of that. That's gone. So that is SFTP. That is a super easy little program to transfer files in SSH. So let's talk about using rsync. The rsync command will work automatically with SSH if you have keys, and it will allow you to transfer files from one machine to the other. And all you need is a tunnel in one direction. If you can log into that machine, we can go get things from the other machine. So let's do that. Let's actually make this work. So we're going to clear the screen, and we're going to use rsync. And we're going to get a whole directory of stuff, because rsync, it does tricks, y'all. It's interesting to watch it work. So we're going to rsync. We're going to use AV for archive and verbose. We're going to use the delete function. You'll see why shortly. And then what I want to do is I want to go to 192.168.0.11 and a colon. And now we're getting stuff from the home directory. Let's go get pictures. And it autofills because it's actually just contacted the host and said, hey, do you have this? It's happening all in the background since we have the keys. The SSH can spin up that quick and come back down. So we're going to grab pictures from the host, and we're going to put them into our local pictures folder. So this is the destination. And so we'll turn that loose, and it's going to grab all those files. So that's bringing back a whole bunch of pictures from the host machine to the guest, or the client. And so now we're going to run that command again. I'm going to show you this because it doesn't do anything. Well, what happened? It knows that it's already done it. It's already figured that out. It's compared the two directories that we put in there, and it has said, oh, well, I've already done that, so I don't need to do it again. All the files are here, and they're the same. But what if I make some changes? So on the local machine here, I'm going to clear, and we're going to run Nautilus, which is the file manager. And we're going to use an ampersand. That puts it in the background so we don't lose control of the terminal while this is running. So there's Nautilus on our local machine. And we're going to go into pictures. And you can see that, well, let's go ahead and just delete that radio pics. Just get rid of it altogether. So we've deleted that. And now what we're going to do is we're going to create a new folder here. And we're just going to call it nothing. So I have made changes locally. And let's say that I have made changes on the host as well. Either way, it doesn't matter. It could be on either end. So now let's run that rsync command again. Now watch what it does. It grabbed the stuff that we didn't have in that radio pics directory. And it also, before it did that, deleted nothing. So if you use rsync like that, it's a hell of a way to back things up, because it will make an exact copy from the source to the destination into a directory. Now there's a couple of things that I want to point out here. If I were to issue that command again, so let's go ahead and Control L and bring up our command. And this time around I forgot to put this little slash at the end. Watch what happens. It's going to go get everything again. Why is it doing that? Well, it's because that little change told the system that we don't want the contents, we want the whole directory. So if I go back here and open up Nautilus again, and we open up pictures, well, open up the right directory, it helps, not music. Pictures, please. Thank you. You're now going to see that we have a directory in here called pictures. And that directory contains all of the pictures that we just put in there. Every one of them. So it's just a duplicate. So be very careful about that. And of course, to fix that, it's super easy to do. all you got to do is reissue the command, and watch what this does. It's going to go and it'll delete that for us. There you go. So that's how rsync works. I did like an hour-and-a-half long video about rsync. It was the first thing that I had posted about Linux in a long time. If you're really bored and you have nothing to do, go watch that video. It's it's a bit tedious. So that's rsync, and that's how that works. Now, the next thing that I want to show you is how to set up a permanent share or a semi-permanent share. And that would be using SSHFS. So what we need to do is make sure that that's installed. So I'm going to go ahead and do sudo apt install SSHFS. This is not usually installed by default. Let's see if it's here. Invalid. Oh, I misspelled that. Because you forgot the A, man. Yeah, I know. Missed that the first time around, so that package is installed. Now we're ready to use it. SSHFS works a lot like rsync. It works the same way. So what we need to do is we need to plan this a little bit, because what we're going to do is we're going to access a directory on another machine, and we're going to open up a tunnel to it so that we can transfer files back and forth. And this is going to appear on our local machine somewhere in the file system. You can do a couple of things. You can create a new directory, or in this instance, we're going to grab a directory of the same name on the other machine and put it into a directory on this machine. So this is a virtual machine, and there's nothing in the music folder, right? Well, I just took everything out of it, so you know, but just in case you don't believe me, there ain't nothing in there. But what if I want to access my music collection on my big host machine and have it available to me? I can set up a share to do that. So let's do it. Simple. SSHFS. And the first thing that we need is the folder or directory that on the host machine that we want to get a hold of. So this, you could think of it as source. And so this is going to be 192.168.0.11. And we're going to use that colon again. It's the same syntax as we used with rsync. And now we're going to put in music. And we're going to mount that into music. And that's it. So now look what happens when I go up here. I'm going to ls music again. Well, look, all that stuff appeared. There's a bunch of directories in there full of songs. How cool is that? Well, that's because we have set up this system. So let's open up Nautilus again, because I want to show you how that looks in Nautilus. So we'll go to Nautilus, and we open that up, and it knows that it's a shared directory, so it tells you. And we do have two-way control here. We can read and write in both directions because we own both of the directories. The permissions will figure themselves out. If you are logged into another account with another name, like you're logged into another user's account, any files that you create are going to be created with your ownership, so it gets a little weird. But for what we're doing, if you have ownership of both directories, everything should be smooth sailing, and I should be able to open up a music player here in my virtual machine and play music if I wanted to. What if you want that to be permanent? Well, since we have SSH set up with keys, then what we can do is we can add this command right here to the startup on this machine, and that's super easy to do. What we do is go in here and go to Startup Applications. Well, if you get it right, it'll show. Okay. And so we're going to do Startup Applications right there. We're going to add a new one. So we click Add. And we're going to give it a name. We're going to call it Music Share. so we know what it does. And then we're going to take this command right here. I'm going to copy it. Now this is one of the reasons we have to have keys. If we want to do this, this is going to be happening in the background. So where it says command here, we're going to paste that in. And I'm going to triple check that there are no extra characters in here, that everything looks the way it should. Yes, that looks good. And we put a comment down here, whatever you want, get some tunes. We'll add that. And now we have that. So when this machine boots up, it's going to automatically connect that. We'll go ahead and disconnect it manually right now. I want to show you how to do that. So the command that you would do to disconnect, it would be sudo umount. And you do need to have elevated privileges to use umount. It won't do it if you just put umount in. So we're going to umount, and then we just give it the local folder that we have our distant directory mounted into, our network share. That's where it's at. So we're going to do that. And now it goes away. By the way, this is just because we're running, we've been running graphic applications in the background. That's why it's coming up that way. So now if we ls music, it's empty because we've undone that. So let's see if we automatically can get in there. So I'm going to reboot the machine, the virtual machine here. And it should automatically connect when it reboots. Hopefully it does. The video will not end until I get it to work. I promise you that if it doesn't work. All right, so we're back in. Let's open up Nautilus. We're going to see if we see the music share. And we do. Look at that. All of those lovely tunes are available to us, and they're not really stored locally on the machine. All of that is happening through the network. So that is how SSHFS works. SSHFS is awesome. So the last thing I want to show you is X forwarding, and then we'll get into making this a little easier with SSH in and SFTP in. So let's go here, open up our terminal again on our host, or rather on our client. And what we're going to do is we're going to run a graphic application through SSH. This is the power of X and Wayland, is that they have the ability to run a graphic application and have it running on another machine, and you can see it on this machine, and this machine is actually just getting the information about what's going on over there and drawing it on a screen. So we want to SSH, and we're going to do 192, well actually I want to put this in first, SSH with X, and that tells the system that we want X forwarding 192, and yes, this works with Wayland 168.0.11. So we're getting into the system. Looks the same as it ever did. But now, if I issue a command like Nautilus, and we're going to put that in the background again so we have control of the terminal. It's going to take a little while to open because we're pulling the information through the network. So don't be discouraged if this takes a couple of seconds. There it is. And give it a second to populate. There we go. Hold on. Let's look at home. And you may notice that it runs a little bit slower through the network. And it's like it's having a little bit of a problem displaying what's in the network there. Oh, you know why? It's not liking that. It shouldn't be a problem, but of course it is because it's a video. It works all the time, but works all the time for me, but now it's not working because we're making a video. So let's do that. Let me get out of here. Oh, you know what the problem was? I wasn't logged in. Okay, now I'm in Big Boy. Let's go to L. Let's just do Nautilus. This time I won't put it in the background. See if that's the problem. Maybe it didn't like that. And it does take a few seconds to open. And there we're on the screen. And apparently this isn't going to work because I'm making a video. Of course. You get the idea, though. Let's open up something that works, shall we? And look, it's even kicked me out. Let's try this one more time. This one I know will work. Let's do... we're going to open up GNOME disks. This is a simple little utility that you work with disks on. So yeah, see, that's working fine. So we're looking at the hard drives on the host machine, and we're doing it through the network. That has no issue. For some reason, Nautilus doesn't like it. I don't know why. You know what? When I was getting ready to make this video, it worked. So I don't know why it's not working now, but you get the idea. So this works with simple graphic applications. You're not going to be able to pull a web browser through here. Let's try Nautilus just one more time. See if I can get that to work. And then we'll let it go because it worked before. I don't understand. Why is it not working? Because I'm recording. It always works that way. Because I do this all the time. I pull stuff over the network like this all the time. Maybe it's because it's a virtual machine. I don't know. Okay. We'll give it a second and let it figure itself out. And let's see what we got here. Now let's see. Hold on. It is running. It's just running very slow. No, let's wait. I'm now going to give this another few seconds to see whether it actually populates this. Well, never mind. You can experiment with it if you want to. Different applications run differently through X forwarding, but a lot of times it's very useful. So the last thing that I want to show you is SSH in, which are these little scripts that I wrote years ago to make this easier to do. And yes, I said I know we weren't going to edit files and that sort of thing. But what we're going to do is this is super easy as far as a script is concerned. It's like you can set this up really quick. So let's go ahead and cat bin, and this is SSH in we're going to look at first. And this is this super tiny little script right here. Okay? And we have the shebang, and then an explanation. This is not in the description. This is all old information, guys. EasyLinux.com is gone. That's right. SSH with the X forwarding already turned on. And then what this does, it's just this is stupid little stub command. It's so easy. Is that it issues the command and then it goes and figures out whatever you type in as an argument. So if I do it this way and I do 11, you see it puts me right into the system. Now, of course, if you're going to be adapting this for use on your own system, you're going to have to put in your own IP addresses to make that work. But if you want to do that, it's really stupid simple to do. So if I cat this, and then you copy it and you put it into a file, make the necessary changes, and then make that file executable and put it somewhere where it will run, like a local bin directory. I've been telling you you need to create one of those. Then it will let you not have to type the entire IP address. I also have SFTP in, and it works the same way. So we're in SFTP. By the way, there's another way to get out of SFTP, and that's by. Earlier I used exit, I believe. So thank you for watching the video. SSH is awesome, and it's powerful, and there's nothing like it on the planet as far as giving you the ability to administer many, many different computers. Anything that's running SSH you can log into, whether that be an embedded device, a little server, or a great big desktop machine. And once you have SSH installed, there are also ways to bring entire desktops across, like using remote desktops. And I don't do that, so I'm not an expert on that. But once you get this basic system set up, I'm sure that it's not too far to be able to do that as well. So good luck. Have fun. Thank you for watching this video. I have to tell you guys, I've taken about 20 different takes to make this video because there's so much to cover. And of course, whenever you hit that record button, things get flaky, just like that little deal with Nautilus earlier. And it doesn't do what you want it to do. I think that's one of the reasons that I have only done a video like this once or twice before on this channel, is because once you understand how it works, you can set it up in 5 minutes. But there are a lot of details to cover. So thank you for hanging out all the way to the end here. It is most appreciated. I'm looking forward to your comments and suggestions. We will do it again soon.